Okay, in this video I'm going to continue showing solutions to homework 3, I believe it is. And I'm going to start with number 5 here. And we're given an MFSK system. And they show a picture, which I haven't reproduced here. But there's a table showing 8 entries, frequencies 1 through 8. And for each frequency we see 3 bits. And so there are 3 bits per symbol based on the lookup table with 8 rows. And so the number of symbols is 8, and L is 3 bits per symbol. Okay? And the sequence of bits is easy to extract from the figure. Basically what you do is you look at the figure which shows the time sequence of frequencies, and it shows frequency 5, then frequency 1, then 4, then 3, etc. And we can read the bits right off of the table for each of these frequencies. And so this is the sequence of bits. Okay. It then asks for the baud rate and the bit rate. Well, the baud rate, well, if you look at the plot, which again I haven't reproduced here, you'll see that there's one frequency for every microsecond. That is one symbol every microsecond. And so the baud rate is 1 symbol per microsecond, or 1 megabaud. The bit rate now is going to be 3 times that, because the bit rate is faster than the baud rate by a factor of L, and I'm going to have 3 megabits per second for the bit rate for part D. Moving on to number 6, we have QPSK, and it asks to show that the equation 1 up here yields equation 2. In fact, it's a lot easier to go the other way, to start with equation 2 and show that 1 follows. In any case, you're going to use this. You're going to take I and Q to be plus minus 1 values rather than 0 and 1. And we're going to use the cosine A plus B identity. Cosine A plus B is cosine A, cosine B minus sine A sine B. And so let's just do one of them. Let's let I and Q be 0. In fact, they're supposed to be negative 1 when they're 0. Okay? Then let's look at the 0, 0 element here. That is cosine of 2 pi fc minus 3 pi over 4. Well, if I take the cosine of 2 pi fct minus 3 pi over 4 and apply the cosine identity to it, I get cosine times cosine minus sine times sine. But both the cosine and the sine of negative 3 pi over 4 are both negative 1. And so now we have a negative, actually they're both 1 over root 2. So this right here should say 1 over root 2. Because this is the unit circle here. So the points on these 4 corners are at 1 over root 2, the xy coordinates for them. In any case, we get negative 1 over root 2 cosine minus negative 1 over root 2 sine, and that boils down to negative 1 over root 2 cosine minus negative 1 over root 2 sine. And if we look at that and compare it with equation 1 above, in equation 1 above, I and Q are the thing in the numerator above the root 2, in an equation where the term in front of the cosine is positive and the term in front of the sine is negative. So we can identify these two values, negative 1 and negative 1, with I and Q. So I and Q being negative 1 gives us the 0, 0 case. Okay? And at this point I just say similar calculations yield the other 3 if we note that at pi over 4, both the sine and the cosine are root 2. I'm sorry, these are supposed to be 1 over root 2. This is supposed to be 1 over root 2, and so is that. Okay. So those are all supposed to be 1 over root 2. And for 3/4 pi, we have this. We have the cosine being negative and the sine being positive. And for negative pi over 4, the cosine is positive, whereas the sine is negative. And you can see that here. And those, this unit circle then gives you all 4 cases. Similar calculations. And I think I'll stop here on this one. So this is problems 5 and 6 here in this homework.